13-8 is on translations of trigonometric graphs, and our first definition is a phase shift, which is a horizontal translation of a periodic function. A horizontal translation of a periodic function. We have some formulas here. So y equals a times sine of theta minus h. Y also equals a times the cosine of theta minus h. And y equals a times the tangent of theta minus h. And then if h is greater than 0, we're going to shift it to the right. If it's less than 0, we shift it to the left. Notice it has that minus sign, so we're going to change the sign. So that will help us to answer these questions. So a is 2, b is 1, and then h is negative 45 degrees. A, b, and then h changes signs. So for amplitude, it's absolute value of a. So amplitude equals 2. The period is 360. Remember, it's cosine, so same rules as last section. 360 divided by the absolute value of 1. So 360 divided by 1 is 360. And then the phase shift is that negative 45 degrees. And since it's negative, it's going to be shifting left. So that would be the idea there. But h is what we're looking for there. That's the phase shift. And that is 45 degrees to the left. And that's your answer. Vertical shift is a vertical shift or translation of a periodic function. So, again, shift could mean translation. I probably should have said that instead. Again, y equals a sine b theta plus k, y equals a cosine b theta plus k, and y equals a tan b theta plus k. So the k is what we're looking at here. There's no sign change, it's just at the end. If it's greater than 0, it goes up. If it's less than 0, it goes down. Also, when a trig function is shifted up or down k units, the line y equals k is the new horizontal axis, and we call this the midline. So example 2 says state the amplitude, period, vertical shift, and equation of the midline for y equals tan theta plus 3. If you remember from tangent, there's no amplitude. It's not 0, there's just not one. For the period, instead, it's 180 divided by the b, and the b is 1. So 180 divided by 1 is 180. The k is 3, so the vertical shift, I'll write that beside it, vertical shift is 3. And then for the midline, it's y equals k, so y equals 3. That's the equation of our midline. This one formula will be really helpful. So a represents amplitude, or the number you use for amplitude. B is what you use for the period. H is helpful in finding the phase shift, and K in finding the vertical shift. And next we're going to talk about the steps to use here. Step 1, determine the vertical shift and graph the midline. Step 2, determine the amplitude if it exists and use dashed lines to indicate the maximum and minimum values of the function. Step 3, determine the period of the function and graph the appropriate function. And step 4, determine the phase shift and translate the graph accordingly. For example 3, we're asked to state the amplitude, period, phase shift, and vertical shift for y equals 2 cosine 1/2 of theta plus pi over 2 minus 2. So A represents the amplitude, and again we're dealing with the rules for cosine, so it's just absolute value of A. So the amplitude is 2. The period is the full circle. So we've been saying 360. Since it's in radians, we'll use 2 pi divided by 1/2. So 2 pi divided by 1/2. So what I'm going to do here is just do 2 divided by 0.5 and get 4. So that equals 4 pi. So that's your period. And then your phase shift is the h. Change the sign, so negative pi over 2. And then the vertical shift is your k, which is negative 2. So amplitude is 2, period is 4 pi, h or phase shift is negative pi over 2, and k or vertical shift is negative 2. 13-9 is on inverse trigonometric functions or inverse trig functions. You'll sometimes see it called arc sine, arc cosine, arc tan. The other way to do it is just the inverse sign like we kind of talked about earlier. You have domain and range here to help you be able to solve. I think these are easiest on a calculator, so that's how we're going to find it. We are told to find each value and write it in degrees and radians. So we'll write it in degrees, and then you can use, you can change it to radians yourself or use a unit circle if possible. So we have inverse cosine. We push second cosine to get that to show up of 0. So that's 90. So we're going to say 90 degrees. And then in radians, you could do, you could look at your unit circle, or 90 degrees times pi over 180. Degrees cancel. That's 90 pi over 180, which reduces to 1 over 2. So pi over 2. So 90 degrees and pi over 2. For arc sine, just inverse sine. I'm going to get a fraction. We have negative radical 2 over 2. And so for degrees, we get negative 45 degrees. And then to change that to radians, negative 45 degrees times pi over 180. So that's negative 45 pi over 180. And I'm just going to reduce that, divide by 180, math, enter, enter. It reduces to 1/4, so negative pi over 4. So for arc sine of negative radical 2 over 2, we have negative 45 degrees and negative pi over 4. Again, you could use the unit circle if you didn't want to do that by hand, that changing from degrees to radians. For example 2, we're asked to find each value and round to the nearest hundredth, so 2 decimal places. It says sine of the inverse tan of 3 over 8. And then I'm going to close both parentheses. And we're round to 2 decimal places, so 0.35. Okay, and then we'll do cosine, inverse cosine, get my fraction, negative radical 2 over 2, then close both parentheses and get negative 0.71. So that is finding each value and rounding to the nearest hundredth. And then for our last one, if tan theta equals 1.8, find theta, well, that means we have to move tan over. So that's inverse tan of 1.8. We actually kind of already talked about this when we first mentioned inverse. So second tan, 1.8. It does not tell us how many decimals, so we'll just do 1. So we're going to do 60.9 degrees. And that is all for section 9 and for chapter 13.